gas expanding, but when you press the piston, by increasing the pressure, what happened? The gas, what happened? Compressing here. So if we apply the pressure, gas is getting compressed. If we release the pressure, releasing means what happened? Removing the pressure. Then what happened? Gas is getting expanding. A process in which the difference between the driving and opposing force is very small. And by increasing opposing forces slightly, the process can be reversed. So I have applied the piston and I have released the piston. Both I have taken. In this process, the difference between driving force means what happened? What is the difference? Driving and opposing forces is very small. Driving force means what actually you're using? You're applying the piston, increasing the pressure. That is driving force. Opposing force means when gas expanding, no. When gas is what happened? Expanding. When it expands, when gas is what happened? Pushing. They're pushing the gas is pushing the piston. Isn't it? So in that case, what happened? When driving force and opposing forces are having very small difference. Very small difference it is. And by increasing opposing forces slightly, the process can be reversed. Okay, when you what happen, whenever gas is what expanding, so again it is what reversing. This type of things are called what? Reversible process. Generally what happen in nature, we'll see irreversible process here. That will discuss spontaneous and non-spontaneous. So understood here? Whenever if you get driving and opposing forces are what? Very small, then they are called the reversible process. What is irreversible process? A process in which what happens? Difference between the driving and opposing forces are very large. And by increasing opposing force is slightly, the process can be what? Reversed. You can reverse that. But generally what happens? The driving and opposing forces are very large. This is the definition for us.
So process can't be reversed.
Yes, beta?
The reversible process can't be reversed, I think, in this.
By using what? It can be done. But generally I told you no. Natural processes are irreversible only. By applying force, we can do that one. You see what happened? Flow of water, tell me beta. Reversible or irreversible? Irreversible. The flow of water.
Irreversible.
Always water will flow uphill to downhill, right? Up to down. Correct or not? It will always flows downhills. It is irreversible process.
Yes,
But if we use motor, water can flow what?
yes, sir.
Reverse manner. Now you see all natural processes are reversible. By what? Temperature, heat will flow always from where? High temperature to low temperature. A process in which heat is not allowed to enter or leave the system, this already we discussed here. No, yeah, no problem. No need this. This already we discussed. Only. Now let me see this heat and work here, so that in this we get everything. Remaining things we get here. Heat and work now. Let me see. Now, when you observe what? For any system, we can increase the energy and we can decrease that energy by using different methods they are having. Two common ways if you observe what happened, heat and work. By using heat and work, the energy of the system may change here, right? Next, let me see heat. Heat can be represented by small q beta. The symbol we are using for heat is what? Small q. What is the definition generally if you observe? It is a form of energy. It is a form of energy which flows from one system to another because of the difference in the temperature. For example, a system you are having, A system is having, body A person is having what something, two persons are there here. Person is what happening, having something what, temperature something what, 36 degrees Celsius. Another person is having what, 37 degrees. When these two are meeting with each other, when these two systems are meeting with each other, now heat will flow from where? 37 to 36 or 36 to 37?
37 to 36.
Always from high to low actually. So the heat always flows from one system to other system because of difference in the temperature. Whenever they get what happened, equilibrium, both are getting 36 degrees Celsius. Both are having 36. Now in that case, what happened? Heat never flows between two systems actually. So whenever the temperature difference is there between two systems, then heat will flow from high to what here? Low temperature, isn't it? Now, what is the sign conversion for heat? When you take heat is absorbed, whenever you say heat is absorbed, Q is equal to positive beta. Q is equal to positive when you get, if it is endothermic. If it is endothermic, Q will be positive. Heat is absorbed. When heat is released, Q will be negative. In that case, it will be called exothermic. Exo means what? Releasing of heat. Endo means what? Absorbing the heat actually. These terms are very important for us. Now, what are the units for the heat? What are joules? Generally, we'll take joules per Newton into meter. This is simply joule like that. Okay. Next, what? Calories. Now, this is important. Beta 1 joule is equal to how many ergs? Beta 10 to the power of 7 ergs. 1 joule is equal to 10 to the power of 7 ergs. And 1 erg is equal to how many joules? 10 to the power of minus 7 ergs. And 1 calorie is equal to 4.184. And 1 EV is equal to 1 electrovolts beta. 1 EV means electrovolts, that is equal to 1.6 into 10 to the power of minus 19 joule. So these three terms we have to remember compulsory. All are what important. You can note down these three units. If you know that one, no problem. But if you don't know, practice this one. Joule, calories, EV. Interrelationship is very important because all these terms we use for what? For what purpose we are using? To denote the heat actually. Now, which is more in this case? Sometimes you may get question in MCQs. Calories is more than joules, joules more than air, air is more than what? EV. This is the value in terms of value. Calorie is what? Highest value. Right? Next. Work we see. Work is a form of energy transformed from one system to surroundings or from the surrounding to the system. So work will, for example, if you do the work, doing work means what happened? You are writing something. When you are writing what happened, you are doing some work actually. In that case, your energy is now converted into something what happens, a mechanical work. Okay, so whatever your energy, what happened, is converting into mechanical energy something. Work refers to an organized form of the energy, isn't it? Types of work, mechanical work, electrical work, gravitational work like that. Okay, don't say what happened, carpenter work, like that, don't say what happened. These are what, in terms of what happened, physics form, mechanical work, electrical work, gravitational work. Generally, gravitational work we don't discuss here, electrical work we don't discuss. This mechanical work generally we discuss. Now, what about the sign conversion? This is what sign convention is very important for us. In examination, we get questions in the sign conversions. Very important. Q is equal to negative, Q is equal to positive. Everyone knows this one. This sign convention is very important. Let me see this sign convention. Now, when work is done on the system, when you are doing work on the system, the W will be, work will be positive. When work is done by the system, when system is doing the work, in that case, W will be negative. Isn't it? Let me discuss this one, how it is positive and how it negative is. What are the units here? Work for work, joule, ergs, CGS units, isn't it? Same thing we are doing actually. Now, let me complete this statement and let me see that one, why it is positive and negative. Tell me better, what is an answer for this one?
A positive.
Right.
Positive.
Right.
Positive.
Right. Okay. Is the correct order, beta? Option is correct.
Sir, B.
Right. Very good. Calories,
D.
ergs, and
Fourth.
now we discuss internal energy state function. But I told you now I have to discuss that work, why it is positive and negative. That I have to explain to you. Okay. Now that one. Here you can see the work. In textbook, what happened? We have completed this one. In textbook, you observe what happened. We completed what? Open system, closed system, isolated system, state functions. We completed yesterday state functions. Internal energy is a state function or not, that we see now. Work also we have completed. Now I have to explain this one, that work, it also we completed a little bit. Now this one we need to. This one, work. Work done on the system and what is work done by the system. I will explain this one. Now if I take what here, this is my an empty slide I will take. Now when you do what happen, work done on the system, let me see, work done.
Sir, your voice.
Yes, beta. Yes, tell me. Is it visible? Audible? Visible?
Yes, sir. Now it's.
Yes, sir.
Now I have taken something what I can, a container I have taken. In this container, I have taken some ideal gas I have taken. And I have a piston over here. I have piston over like this. Now the gas is having some value, V1 value. This is initial beta, initial. Now when I apply some pressure, applying piston, applying what happened? Pressure or piston. Now what happens? And the volume here what happened? V2. The volume is what here? V2 here. Same gas, volume is V2. This is final. This is the final. Okay. Now generally what happened? When you apply what happened pressure, the volume from V1 to V2 is decreased. Now this is called work done on the system. You take gas the system, this is a system. Okay. Now the pressure is doing, that means the piston is doing some work on the system. Now in this case, what is a delta V is negative or positive beta? Delta V is equal to V final. You take I here. You take this one as a F here. V final minus V initial or V2 minus V1. V final will be less, correct or not? And V initial will be more, correct or not beta?
Yes, sir.
Yes, sir.
Delta V is negative or positive, tell me.
Negative, sir.
Negative.
Negative only. The
Negative.
delta V will be negative. Now, how do you calculate generally work? By using a formula called P minus delta V beta. P minus delta V. But in physics, you take that one P into delta V. But in chemistry, we'll take minus P into delta V. Conventionally, we'll take that. Now, when you apply this one, what happened? W will be is equal to what? Minus into pressure is what? Something it will be. Delta V will be what here? Negative. Resulting will be positive. Now work done on the system always will be positive.
Okay.
Okay. Now let me take work done by the system. Work done by the system. Here again, piston is there. Here it is what? Gas. V initial or V1 or V initial. Now, again, what happened when gas is expanding? When gas is expanding, in that case, what happened? Work done by the system. The piston is a rest motion, therefore, what happened? It will be expanded here. Here, gas is what compressed here. Compression of gas. Here, gas what expanded. Or when you release otherwise when you release what happened? Piston. Release the piston. The gas will be expanded. Now the gas will get here what? V finally. Now delta V is equal to again same formula V2 minus V1 or V final minus V initial. So definitely V final will be more. V initial will be less. So delta V, the change in the value if we get in positive, will be positive. So in that case what? W is equal to again same formula. Again minus P, delta V will be positive. So positive into negative always will be negative. So work done by the system. Work done by the system will be always
Negative.
in examination. They are asking like this. Following which option is correct? Heat releasing Q is equal to negative and work done on the system W is equal to positive. Like that they will change that. So in examination, you cannot draw these diagrams, and drawing the diagrams, everything will be difficult. No, you remember O positive. This one is correct. No, O positive, O positive, B negative, B negative. Here also remember only one thing. Remember this one only. Remember this one. Now, when you observe what happened, 100% of population, if you observe, most of the population will have O positive only. Blood group, I am saying. Most of the population will have which type of group beta? O positive. If you ask what happened out of 10 members, they say 6 members, 7 members, they say their blood group is what? O positive. You know that one. So you remember O positive. Leave it the B negative. Because always we say B positive, no? अब सभी लोग आपको क्या बोलते हैं? B positive. कोई ऐसा बोलते B negative? You have to be positive. So B negative is not correct. Correct or not? So always take what? O positive. Why? Because in examination, definitely it will confuse you. So to avoid the confusion, what I'm saying, O positive. Remember O positive means what? Work done on the, O for what? On the system. On the system positive. If it is positive, by the system will be definitely negative. So don't remember both these one. Only remember O positive only. Opposite will be B negative. Understood beta? Because this is one. Understood?
Yes, sir.
Now let me take the internal energy now. We'll see now internal energy now. The state function. Just now I showed you know in your textbook whether internal energy is a state function or not. Let me discuss this for you. First of all, we'll see the internal energy. Every system has some quantity of matter associated with a definite amount of energy. This energy is called what? Internal energy. Whatever the amount of energy carried by the matter, that energy you are calling as internal energy. Summation of all the energies also we can call internal energy also. It can be represented by U. Delta U, it can be represented here. Now, internal energy, potential we can take, kinetic energy we can take. Potential energy is what? Intermolecular energy. The energy, attractive forces present between the molecules. Intramolecular energy within the molecule. H2O and H2O will have some attraction forces. H2O will have some attraction forces here. Within the H2O, some type of attractive forces will be there. Nuclear energy or binding energy. All this comes under potential energy. I think you know kinetic energy is very simple, you know already. Motion energy generally called vibrational, rotational, translational, electronical energy. All this comes under in kinetic energy. That means the sum of what? Electrical, translational, rotational, vibrational, plus what happened? Potential energy. Then all this comes under what here? internal energy. Potential plus kinetic energy is called what? Internal energy. It can be represented by what? Capital U beta. Capital U, it can be. Old books, they say given E actually, but this is the new nomenclature. U, capital U is the nomenclature. It is an extensive property. Now, what is the meaning of extensive property? There are two properties will be there, beta. Extensive property and intensive property. Just I will explain definition. Later we will take number of examples. Now, what is the meaning of extensive property? Means the properties depends upon the quantity of the matter. They are called what? Extensive property. The properties which depends upon quantity of the matter is called what? Extensive. Quantity. For example, heat is extensive property beta. I am saying what? Heat is extensive property. Why? When I take more amount of matter, I can produce more amount of heat. Volume is extensive property. Volume is extensive property. If I take more quantity matter, I have taken more quantity, volume also I will get more. Mole is extensive property. Why? Because if I take more amount of weight, we will get definitely what happened? More number of moles actually. So what I mean to say is that anything which depends upon quantity of the matter, they are called what? Extensive properties, right? Now, what is the meaning of intensive property? Intensive property means which do not depend upon the quantity. They do not depend upon the quantity. For example, if I take 1 ml of water, I'm taking 1 ml of water. What is the boiling point, beta? What is the boiling point?
100 degrees
100 degrees.
Celsius.
If I take 1 liter of water,
Celsius.
if I take 1 liter of water, 1000 liter of water, what is the boiling point of water?
100 degrees Celsius.
Same only, no? That means boiling point is not depending upon the quantity. Similarly, what happened? Freezing point also. So we come back across later this one for everything. But what I mean to say here, internal energy is extensive property. That means if I take more quantity, I will get more amount of internal energy, right? Second thing is a state function. Many number of times in the last class, state function does not depend upon the path. How the change occur, it doesn't consider actually. It depends upon initial and the final state. If you want to calculate the internal energy, how do I calculate? The change of the energy, final state minus initial state is nothing but internal energy. We don't consider the path. It does not depend upon the path followed. I told just now we are discussing this one only. No, it does not depend upon the path. What path it is occurred, the change is occurring in which path, it does not consider that. There is no change in the internal energy in the cyclic process. When you consider the cyclic process, internal energy will be always zero. For cyclic process, delta U always will be zero. Nothing is done in that case. Nothing energy is what? Changed in that case. Next, a system undergoing series of process once again returns to the original state is generally called cyclic process. Yesterday we have taken this one with example. Again, it is getting what? Into original state here. A is converting into B. Again, B is converting into what? A, isn't it? That in that case, what happens is cyclic process only. In that case, internal energy will be always the change of the internal energy of A is equal to, otherwise, the internal energy of A is equal to internal energy of B in this case. Both are what having same. Then only what happens, cyclic process will occur. Internal energy of an ideal gas is a function of temperature only. That means what happens when you increase the temperature, definitely that internal energy also will increase. If temperature is constant, delta T is equal to 0, internal energy always will be 0. This is the main important, and I have taken a star mark for this one also in the yesterday class. Whenever temperature is constant for isothermal process, for what? Isothermal process where delta T equal to 0, in which what happen, internal energy also does not depend. So what I'm saying is a function of temperature. That means it depends upon temperature only. What are the units here? But energy. Internal energy will have same units like energy. Energy units are what? Nothing but joules, eggs, calories, like that we can take actually. Joules when we take beta, SI units. X will take what? CGS units here. Let's see the change in the internal energy by doing some work actually. So we have to explain what happened, the state function of internal energy. Take a system containing some quantity of water in an insulated thermoflask beta. So we are taking some water in where insulated thermoflask. Insulated thermoflask means what happened? Change of matter, exchanging of matter, exchanging of heat cannot be takes place. Understood better? Exchanging of heat, exchanging of matter cannot take place in insulated thermoflask. In that I have taken some water, right? Let us bring the change in the internal energy of system by doing some work on it. I am doing some work on the water present in the insulated thermoflask. Let us call the initial state of the system is a state A. The temperature I am taking TA. And internal energy also we are taking UA. So initial state A, for the temperature is what? TA, internal energy is what? UA. Next. We can change the state of the system in two different ways. Let me see that one. One way, by mechanical work of some amount of, how much energy? Something 1 kilojoules is done by rotating the set of small pedals and churning the water. Just you are agitating the water, rotating that water pedal in the water within the insulated only, within the insulated flask only. You are doing some work. Work done by rotating. How you are doing the work? By just rotating the pedal. You are agitating that one. Like this. You are doing what? Like this. In that case, what happened? Let the new state B and its temperature is what? TB. Now what happened? You got the final state. You got the final state B and temperature is what? TB. Internal energy is what? UB.
चलो शायद हाइट हो रखा है सर वो आपका हॉटस्पॉट ना हाँ शायद हाइट हो रखा है
just a minute better. I just will continue this one. Just wait for 1 minute. हाँ सर HP means I don't know.
मोबाइल आपका ये HP का है ना लैपटॉप
नहीं सर ये डेल है ना
हाँ HP का
हाँ ओके नेट आ रहा है ना
पासवर्ड बताने से इसमें
वाईफाई कीजिए हाँ इसकी वजह से नहीं
हाँ इस वजह से नहीं है
ये है सर पास 55 के 55 डबल कैपिटल के
55 कैपिटल के
स्लैश 69 E6 स्मॉल E 69
E6
स्मॉल E6
वो उसी वजह से शायद
अच्छा ब्लूटूथ तो हो गया इसका होगा सर 10 मिनट में हो जाएगा ना
हाँ मेरा हुआ ना एक्चुअली इससे इन सर्विस सेकंड्स पे 11 o'clock है 11 क्लास है
Right, beta, we are just doing what? Some agitation we are doing, something rotating the pedal actually. Because of this rotating this pedal, we are getting final state beta. That final state we are calling as B, and temperature you are calling as TB, right? Internal energy you are calling as UB. Okay, for final state, whatever the internal energy of water will be UB, the temperature of the water will be taken as TB. Now we got initial and the final state we got. Now when you observe here, definitely after doing this rotation of water, that means rotating that pedal inside the water, temperature will increases or decreases better inside that water system. So TB always will be greater than TA, and delta T is equal to TB minus TA. So if it is increasing, same thing it will happen. Okay, same thing it will happen. Now second way I am doing here. Now second way of changing the system here. Equal amount of work with help of an rod, something like this. You are placing something, you will heat water, no? Intersection definitely. We use heater. We'll keep that heater in the water, in the bucket of water. Definitely what happens after a certain time, the heat will be increased, water will be heated. Here delta TB you take same, TB minus TA. The difference between the value of U in two states taken as delta U, which is the adiabatic work required to change the system. Let me see this one here. Now delta U is equal to UB minus U. You are taking adiabatic. Why you are taking adiabatic? Anybody? Anybody? Why you are taking adiabatic? Why you are taking adiabatic beta? Yes?
Heat is constant.
Because the water we have taken where? In isolated system, in a thermal flask, in which heat is cannot exchange with surroundings. So definitely this work will be adiabatic work beta. The work will be always what happened? Adiabatic, because the system is in which phase? Which system? Isolated system. In
Isolated system.
Therefore, I have taken adiabatic work. In that case, change the internal energy is equal to final internal energy minus initial internal energy. That will be equal to what? Work done on the system in adiabatic process. Now, the change in the internal energy is the same in the above experiments. That is internal energy in a state function. Now here, I have taken pedal. I have rotated this one. I have agitated here. Second thing, I have taken something what heater. That heater. I have taken heater here. So mechanically, you are doing different works, different type of path you have taken. I have taken pedal. I have taken heater. But in both the cases, delta U change here, the change occurring is what same. For example, by using this pedal, T1 is what something what happened, something 30 degrees Celsius. T2 is something what happening, 31 degrees Celsius. So delta T is equal to 1 degree Celsius. When you take heater, what happened? T1 is something again 30 degrees Celsius, isn't it? Or something what happened? Whatever it may be, 30 degrees Celsius or something 40 degrees Celsius. 40 degrees. And T2 is what? 41 degrees Celsius only. Delta T is equal to 1 more. In both the case, what happened? The change is what? Same thing. The internal energy, I'm saying, in terms of internal energy, you take U1, U2, U1, U2. The delta U is what? Same in this case. That means if you do this one, at what? Compulsory in adiabatic conditions. The heat must not be exchanged with what happened? Surroundings. In that case, what happened? Definitely same thing here. That means here, what I'm saying, internal energy is not depending on the path. It is depending on what is initial and what is at final. Understood here? Tell me better, what is the answer for this one? Does not include what?
The C.
Energy arising gravitational.
The C.
Which we don't consider general. Gravitational pull generally we don't take as internal energy beta. Already we have discussed in this way. Or what happened? Potential energy, intra, binding, everything is a potential energy. Next, we'll see the work done expression for isothermal process. When you take isothermal process, that means temperature is constant. What is the work done in this case? Now, consider an ideal gas in a cylinder which is fitted with a weightless and frictionless piston. This one, which is a weightless and frictionless piston. You are having which gas beta? Ideal gas here in the cylinder. Next, pressure I have taken P1, volume is V1, and temperature is constant. Why temperature is constant beta? Because whatever we are taking isothermal process. The experiment is what in isothermal process. Temperature is variable is what P1 and V1. If gas expands, it pushes the piston upward direction. Work done by the system. Work done by the system, the gas expands and pushing the piston upward direction because weightless, frictionless piston we have taken. So definitely the piston will move to upward direction. Next, we got like this. This much amount of pressure, what happened? Changed here. Now, this is what actually after expanding, this is the pressure. You are calling this pressure is external pressure. Because here what happened? Gas expanded completely, what happened? So whatever the pressure is there at external condition, in air, whatever the pressure is there, so that pressure I am calling this one as external pressure. Isn't it? This is the pressure of atmosphere. External pressure we are taking, P external. And the volume changes into V2. Volume changes into V2. Next. Work done is equal to opposing force into displacement. Formula generally will take in physics. Opposing force into displacement. Opposing force because work done by the system. Definitely what happened? Opposing force I have taken as a minus. Negative sign because it is expansion. Right? Displacement we have taken D. So, opposing force I am taking as what? P external. The pressure at external condition I have taken this one. Right? Into A. Area. A is nothing but area beta. So, force is equal to already you know this formula, isn't it? Work done is equal to minus P external V2 minus V1. Why we got V2 minus V1? Because area into displacement will be called value. Change in the value. So this will be the formula work done. Formula minus P external into V2 minus V1. This will be the formula. Just now we seen this formula for what? Work done on the system, work done by the system. Sign conversions. W is equal to minus P delta V is the formula for work done in isothermal process. During expansion, V2 is greater than V1 and delta V positive, W will be negative. So work done. In this case, what happened? By the system. Work done by the system. Next, during compression. In compression, what happened? Volume decreases or increases beta in compression process?
Decreases.
Decreases. So delta V definitely negative. Work will be positive. So this is the table. Just now we discussed here.
Excuse me, sir.
Bolo beta. Healthy bolo.
Sir, in this experiment, how the gas can expand? Means the temperature is constant.
Beta, repeat that one.
Sir, in this experiment, how the gas can expand? Because for expansion of gas, temperature should increase.
So why? Because the gas is having more pressure inside the gas. Whatever inside the cylinder, whatever the gas is having, that has more pressure. So because of that pressure, what happens? It will expand here. When you will compress beta, when gas will be compressed, when you do the compression of gas beta, when you do the compression of the gas, right? In what methods?
Increase in pressure.
So same thing is happening same there also. Whenever an external pressure is what? Remember this, external pressure is what? Low. Expansion of gas takes place. Whenever external pressure is more, compression of the gas takes place. That means external pressure depends here. Understood better? Depends upon what? External pressure. If external pressure means, you take again the final, the last diagram. Here, in this case, the external pressure is what? Less. So gas is having more pressure here. So that is the reason gas expanding here. Right? Already we completed here. Just to see. Do you have class now, beta? Anybody is having class now?
Yes, sir.
Which class you are having? Which class beta you are having?
So at 11 o'clock, bio students will be having.
At 11 o'clock you are having bio class. Now
So,
just I will take 2-3 minutes only. I will take 2 minutes, 2 or 3 minutes only. I will take. Just I will complete this only.
Okay, sir.
Right. If I take vacuum beta, if I take vacuum, in vacuum, internal there will be no pressure, right? Everyone knows the vacuum, no? There will be zero opposing pressure. In vacuum, what happens? Opposing pressure will be zero. The external pressure will be zero. So in that case, work done in vacuum always zero or not. Tell me beta. If P is equal to zero, if this value is zero, W also will be zero or not. In vacuum,
Yes, sir.
pressure will be zero.
Yes, sir.
In isobaric system, what is the meaning of isobaric beta?
The
Pressure
pressure is
is
constant.
Pressure is constant. That means pressure is not changing. When pressure is not changing, what happened? Delta P equal to zero. Now W is equal to what here? Minus P delta V. When delta V equal to zero, W equal to zero. Now actually what happened? Pressure is constant means what happened? Not changing means what happened? You take 2 atmosphere. Take 2 atmosphere. Because I am not taking delta. I am not taking, because P is pressure, isn't it? What happened? I'm not taking delta. Delta means what happened? Change in the pressure I'm not taking. Yet pressure is constant means what happened? The change in the pressure is zero. Delta P is equal to zero means what actually? The change in the pressure in the system is what? Zero. But external pressure we are taking here. That may be 2 atmosphere. That is not changing. So that will be what? Consider here. But delta V means what? Will not change. Therefore, you have to retain that. But when in isoporic process, volume is what changing, delta V is changing, and here also it will be zero. In that case, what I mean to say is here, work done in vacuum, in isoporic process, will always will be zero. Work done in isobaric process, where external pressure is not zero here. Therefore, what happened? We are getting W is equal to minus B delta V. So this is very important for you for 1 mark question beta. They're asking this type. I think if in your textbook also many number of questions are there. The first, second, third questions are related to this topic only. So remember in vacuum, isobaric process, work always will be is equal to zero only, isn't it? Formulas, you remember these formulas here. Okay, work formula, pressure formula, value formula. This is that work formula minus P delta V. And this is very, very, very important formula beta. 1 liter atmosphere is equal to 24 calories or 101.3 joules or 101.3 10 to the power of 7x. Remember this one. Useful in the problems. Remember this one. 1 liter, because if I take volume in terms of liter, if I take pressure in terms of atmosphere, work we get in terms of which units beta? Work I will get in terms of which units beta?
Joules.
Liter atmosphere. Liter atmosphere. But work can I take, if I say what happened, I have done something, 22 liter atmosphere amount of work I have done. Anybody understand? Nobody understand. I have to convert this liter atmosphere into compressor into joules. In that case, I told you 1 liter atmosphere is equal to 101. For example, some pressure is given. Something what 5 is the external pressure is there. 5 atmosphere is the external pressure. The change in the volume is what happened? 2 liters. The change in the volume is 2 liters. Now W is equal to how much here? 5 into 2, 10 liter atmosphere. Then 10 liter atmosphere I got. The work here done is equal to 10 liter atmosphere. But we have to convert that one into joules. So what is that? 1 liter atmosphere is equal to how much? 101.3 joules. Then 10 liter atmosphere is equal to how many joules here? 1001.3 joules. So that is the reason this is very important formula for you. 1 liter atmosphere is equal to 104.3 joules. If you know the joules, we can calculate, easily convert into calories, because 1 calorie is equal to 4.134 joules. That already you know that. That is the reason. So 1, if you know what happened, remaining we get here. Remember this one, right? And this already you know, 1 joule is equal to 10 to the power 7x. Remaining we'll do in next class here. What the topics will be. How many are there now here? 57. Right. So I will take the attendance beta. 2 minutes.